Hi guys, in section 9.3, we'll talk about how to count elements of disjoint set, which is the addition rule. And actually later on we'll extend it to the sets that are not necessarily disjoint, which is the inclusion and exclusion rule. So let's begin with the addition rule. And it says, suppose a finite set A equals the union of k distinct mutually disjoint subsets A1 to AK. So to visualize this scenario, basically you have a set A, and then this set A is equal to the union of the sets, say A1, A2, A3, A4, and dot 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 to AK. Now this rule says, how do you count the number of elements in A? You just add the number of elements in all these subsets. Well, because they are mutually disjoint, they have nothing in common, so you won't be double counting, okay? And you won't miss any counting because they union to A. The proof of this theorem is quite doable with mathematical induction. So I would like to challenge you to give it a try and try to prove this rule. The second theorem, which is also very intuitive, is called the difference rule. It is this. If B is a subset of a finite set A, so let's visualize it. So you have a finite set A, and B is a subset, so here's the B. And then the number of the set A minus B, that means the elements in A but not in B, basically just this part. So how do we count it? It's a number of elements in A minus the number of elements in B. Very intuitive, right? Now let's take a look at how we actually apply the rule. The rules are really simple. However, to be able to use them effectively, you do have to go through a whole bunch of exercises. The trick is you have to find a way to divide the set A into different mutually disjoint sets. So you have to find a way to do that. Now let's take a look at the first one. By the way, the more you do, the better you will be at you will master the skills through the exercises. Okay, let's take a look at the first one. How many 3-digit integers are divisible by 5? Well, earlier in the previous section, we actually learned how to count this problem using a different method. So today we are going to look at it from a different perspective. So just to refresh your memory, earlier this is how we did it. You don't want to just say 3 digits number there, and then you just count how many and then divide it by. I would say just so here. I'm sorry. Here's the way that we did earlier. So the first number, 3 digits number integer that's divisible by 5 is 100, right? And the next one is 105. The next one is 110, and so on, 110. I'm sorry, 110, and so on and so forth. The very last one is 995. Now you can think of this as a list of number, and the first one is like 5 times 21. Okay, 21, the 21st positive number that's divisible by 5. And then the next one is 5 times 20. Actually, I'm sorry, the 5 times 20, that's 100. That's 100. The next one is 5 times 21. The next one in line is 5 times 22, and so on and so forth. The very last one is 5 times 199. Therefore, you really have a list, like the list is 20, 21, 22, all the way up to 199. And how many numbers are in this list? And then earlier we say it's equal to 199 minus 20, the last index minus the first index, but don't forget to add 1, right? So therefore you have actually 180. So that's how we did this problem earlier. Now today, because we introduced the addition rule, we want to kind of come up with use a way to divide all these 3 digits integers into subsets, and they're mutually exclusive, mutually disjoint. Okay, so now the numbers that are divisible by 5 is either ending with 0 or ending with 5. So you have 2 sets. One is the integers that ending with 0. The other set is ending with 5, right? So you have 2 sets, 1 set and 2 sets. And they're definitely mutually exclusive, or that means disjoint. So therefore, to count the 3-digit integer that are divisible by 5, I just need to count this one and count this one and then add them. So that's what the addition rule comes in. So now, how do we count the 3-digit integers that are divisible by 5? So we are going to do a little counting. Ending with 0, that means the very last digit is going to be 0. This has to be 0. So therefore, you have only one way to do that. That means you just choose 0. So one number, you choose that number. So you only choose 0. Only one way to do that. Now, the first digit, because this is 3-digit integer, it cannot be 0, right? But it can be any number from 1 to 9. So how many ways to fill in the first, this hundredth digit? Just pick any one from the 1 to 9 and then fill it in here. So you have 9 digits to choose from. Just pick one. And the second digit, the 10th digit here, any number can be filled in here. So from 0 to 9, any number can be here. So it's going to be, you 10 choose 1, right? And then you did this in 3 different steps. So you're going to use multiplication rule. Step 1, fill in the 100th digit. Step 2, fill in the 10th digit. Step 3, fill in the last digit, which is 0. So only one way. So therefore, you multiply these together. You have 9 times 10 times 1. So now plus, because this is disjoint, these two are disjoint sets. So according to the addition rule, I'm going to plus, right? Ending with 5, similarly, very similar. The last digit, it has to be 5, so only one way to do that. The first digit, you choose from 1 to 9, so only choose one out of those 9 numbers. The second, the 10th digit, you choose any number from 0 to 9, which is, there are 10 numbers. So therefore, 9 times 10 times 1, which is 90, plus 90, which is 180. So quick recap, okay? So for some number, for some problem, there are certainly different ways to approach the problem. And in this particular problem, we apply the addition rule. The key is find a way to divide the sets into 2 disjoint sets, and then count each one and then add them to find the total. Now I'm gonna use separate videos to go through the following examples. So I'm gonna stop